and welcome back to Maths with Mitch. Today we are solving simultaneous linear equations. So what we're going to do today is have a little look back on what is a linear equation, then look at what it means to solve it, and then look at what are the methods. So we're going to look at the elimination method, and I'm going to show you a few nuances with that too. So let's get on with it. Okay, so last time we talked about linear equations in the form y equals mx plus c. We said m was the gradient and we said c was the constant, and we looked at how we can sketch it. So here we have the equation y equals 2x plus 1 sketched onto our graph. Now if we want to solve that equation, we can look at finding the values for x and y. Now if you've got two unknowns in an equation like that, then you can have lots of solutions. So here we can see that depending on the value of x, you'll get a different value of y. And you can have an almost infinite number of solutions, because the solutions are essentially all of the points on that continuous line here that we've plotted. So when we're talking about simultaneous equations, that means you're going to have two equations because you've got two unknowns, and that's going to give you single values for x and y that solve both those equations together. So you're going to end up with one solution of x and y. So if we were to consider a second line here, we'll do it in the same form, y equals mx plus c here, but we'll say y equals minus x plus 2. Now we talked about last time how to sketch it, so we're not going to plot it, we're just going to sketch it. So we can say the point at which it crosses the y-axis is going to be 2, so we can plot that here, that'll be 2. And it's a minus 1. Remember, if there's no coefficient in front of the x, that means that we can say that that's a 1, so it's a minus 1. So that's going to go negative 1 in terms of the direction. So we can draw that on like that. Now that's just a sketch, it's not going to be exact, but what we can see from there is that there's going to be one point at which the two lines intersect. So get my right setting on my pen. So they intersect here, and what we're going to do is find out the coordinates of that point in terms of x and y, and that is our solution to the simultaneous equations. So if we have two unknowns and we have two equations, we can find a point at which those lines cross, and that'll give the single values for x and y that satisfy both those equations in this particular scenario. So let's think about how we're going to do that. So we have our two equations now, and the first thing I want to look at is the elimination method. And that's going to be what we're going to apply for these linear equations. So firstly, with the elimination method, what we want to do is get our y terms and our x terms on one side of the equation, and then it's going to be a lot easier for us to consider how we're going to manage them. So firstly, let's look at let's number these equations. That's equation 1 and that's equation 2. So what I want to do is get this x term over here onto the y term. So remember when we looked at rearranging equations and the equation being a scale on one side and the other of the equal sign. You can look at my other videos if you need a reminder of that. We think about what we're going to do to those x's to get them onto the other side. We want to remove them from the right hand side. So if we have a positive 2x, do the opposite, we want minus 2x. So we're going to have y, and then on the left hand side we'll have then minus 2x. We've got rid of the x term on the right hand side and we're left with just 1. Now let's do the same thing to equation 2. We have a minus x here, so we want to do the opposite and get rid of it from the right hand side. We're going to then add x to both sides. So we'll have y plus x equals, that's a positive 2. And what we're aiming to do here is to effectively make, and let's get a brighter color that's going to actually show that. We want to get the y's in one column and the x's in another column, because now we've got them set up as two equations and we've got them in columns. We can now eliminate one of the terms by either adding or subtracting one equation from the other. So straight away here you can see we have a y in the top equation, number 1, and a y in the second equation. So if we wanted to think about how we could get rid of these y terms, because they're the same term, we've got a positive y and we've got a positive y here. So we could take equation 2 away from 1. So we're effectively saying, or 1 from 2, either way around. So let's do equation 1 minus equation 2. So we have y minus y. So that leaves us with nothing there. I'm not going to draw 0, but we have no terms left there. We've eliminated the y term. Here we have minus 2x, and we said we were minusing. So we're minusing a positive x. So we had minus 2. We're going to minus another one. So that'll be minus 3x. And then we have 1 minus 2 gives us minus 1. And there we're left with just one unknown and numbers, and we can solve for that remaining term. So we can solve for the x term. So there we can then get rid of our minus 3 on the front. Fine, let's draw this like this. Get rid of our minus 3 term here by dividing by minus 3. So what we do to the left, we do to the right. That leaves us with an x on its own on the left, and on the right we'll have minus 1, and that was divided by minus 3, so that leaves us with positive 1 over 3. So we've solved there for x and given us x equals 1 over 3. But we're still left with not knowing what y is. Now the trick here is that you can now put x into either one of these equations, whichever one you think it's going to be easiest to work out, because you're finding a single point solution where the two lines cross, it's going to be the same in both equations regardless of which you put it in. And we'll test that. So if we put it x into equation number 1, we can then say y equals 2 times a third plus 1. That means y equals, we have 2 thirds plus 1 is 1 and 2 thirds. Or we can say y equals 5 over 3. Okay, so we've got a solution there. Now let's try the same thing with, if we were to put x into equation 2, and let's test that we get the same answer. So y equals minus a third plus 2. So we can then say, remembering that 2 is the same as 6 thirds, or 6 over 3. So we have positive 6 over 3 minus 1 over 3. That leaves us with 5 over 3. So we've proved there that that gives you y, the same value of y, regardless of which equation you could put it into. And that's because you're finding that single point at which the lines cross. So our solution there is to those simultaneous equations, x equals 1 over 3, y equals 5 over 3. And that is the point on the graph. So we said 1 over 3, 5 over 3. And if you look visually, we just sketched it before, but you can see that that's roughly what we actually found. So we said that's 1 over 3. And here, that is 5 over 3. And 5 over 3 is between 1 and 2. So that is pretty much correct as a visual check. So you've proved your equation in two different ways there. You put x into both equations and proved to get the same value of y, and also done a visual check, so you can have strong confidence that you've done your maths right and got the right answer. So let's do another one. So here we have two more equations. We've got y equals 5x plus 2. Let's make that equation number 1. We have 2y equals 3x minus 1. So previously when we looked, we had always had nicely y equals mx plus c, but sometimes a linear equation won't be in that exact form when it's given to you. So you need to know how to manipulate them to get them into the form to allow the elimination method. So again, we're going to follow the same process. We want to get them into the columns where you have y's and x's on one side of the equation. So let's do that. So let's look at number 1. Let's move this 5x onto the left-hand side with the y. So if we've got positive 5x, we want to minus 5x. So we're going to be minusing 5x off the left, minus 5x off the right. That leaves us with y minus 5x, and that just 2 on the left-hand side. On the right-hand side, sorry. Now let's look for number 2. We're going to follow the same process. If we got a positive 3x here, we want a minus 3x. So we want to do the same thing on the left-hand side. This time we have 2y minus 3x equals minus 1. Okay, so last time we said with the elimination method, we subtract one from the other and get rid of one of the terms. But that's not going to be so easy this time. If we were to do the same thing that we did last time with the y terms, then we're either going to be doing y minus 2y, and we're still left with a minus y term, or we can do it the other way around. We can say equation 2 minus equation 1, 2y and you minus y, we're still left with a y term. So how do we get rid of them? Well, let's think about if we have 2y here and we have 1y here, we want to get them the same so we can subtract one away from the other. How about if we do equation 1 times 2? So if we do that, 2y minus 10x equals 4. So you're going to just times everything in that equation by 2. Now why is that allowed? It's because if you do the same to the left as the right and you just times it by a factor, you're not changing the equation, you're just changing the coefficients in there, but that doesn't change the values of x and y in that equation. So then if we have equation 2, 2y minus 3x equals minus 1, we haven't changed that, but now we've got it in a format that we can apply the same elimination method that we did last time. So we have 2y here and we have a 2y here, so you can subtract one from the other and you'll be able to eliminate that y term. So let's think here we're going to do equation 1 and we're going to minus equation 2. So we can think of 2y minus 2y, that leaves us with nothing there. We have minus 10x and we're going to subtract a minus 3. So remember, when you minus a minus, you add. So we have minus 10, add 3. That leaves us with minus 7x. And we have 4 minus minus 1. So that leaves us with 5. And again, then we can solve for x. So to get x on its own here, you're going to divide by a minus 7. And do the same on the right hand side. That leaves you with x equals minus 5 over 7. So you've got your value for your x term. So next step, put it into one of your equations. So let's put x into, let's use number 1 because that looks like it's going to be easiest. So y equals 5 lots of minus 5 over 7 plus 2. Let's times the bracket out first. So you've 5 times the top, so we'll have minus 25 over 7 plus 2, which is the same as 14 over 7. So we can add them together. So minus 25 plus 14, that leaves us with minus 11 over 7. And therefore that gives us our answer. X equals minus 5 over 7. Y equals minus 11 over 7. Okay, now let's thirdly look at this problem. So we have 2y equals minus 5x plus 3 and 3y equals 2x minus 1. We're going to follow the exact same process. What I want you to get into the habit of, elimination process, follow it through and you'll get to the answer you want. So firstly, let's get our y and x terms together on the left hand side, get them into the columns that we want to see. So here we have a minus 5x, so we want a plus 5x to both sides. And that'll give us 2y plus 5x equals 3. And for equation number 2, we have positive 2x here, so we want a minus 2x, and therefore minus 2x. So that leaves us with 3y minus 2x equals minus 1. Now here we've got a bit of a challenge because we've got the same problem as last time, that we don't have coefficients that are going to easily disappear if we add or subtract them from one another. But also it's not as obvious to see where you can times them, because previously in the last one we just doubled one of them and we got to the same terms. But here it's not so easy. You could times this by 1.5, but that's when things might start getting a bit messy. So how about we look at the coefficients and think, right, what's the lowest common multiple? So we can then think about what we need to times them by to get them to the same number, to then minus them from one another. So here we can think 2 and 3, lowest common multiple is 6. So how do we get that coefficient to 6? For equation number 1, we're going to be timesing it by 3. So that gives us 6y plus 15x equals 9. And to get this to 6 in equation 2, we're going to be timesing it by 2. That gives us 6y minus 4x equals minus 2. Now, what you might also notice is, yes, I said lowest common multiple, and sometimes you might need to look at what that's, have a little think about what that's going to be, but the majority of the time it's going to be timesing it by the coefficient of the other equation that you're trying to get rid of. So that'll probably be the easiest and quickest way that you can look at it. And now, from that point, you can just follow through our same process that we have been doing. So we have 6y here, 6y here, so you want to take one away from the other. So, as I said, you can do 1 from 2 or 2 from 1, whichever you think is going to be the neatest. Let's do equation 2 minus equation 1 this time. So we're going to look at them from the other way around. So we have 6y here minus 6y at the top. That leaves us with no y terms. Here we have minus 4x minus 15x. So that leaves us with minus 19x. And here we have minus 2 minus 9. So that leaves us with minus 11. And then again, solve for x. So let's divide that by minus 19. Divide by minus 19. That leaves us with x equals 11 over 19. And of course, you're left with fractions. You can look at if you can simplify them down. I don't think we can in this case, so we're going to be left with that as the term. Put it back into one of the original equations. A ruler appearing there. So we can say 2y equals, so going into equation number 1 here, 2y equals minus 5 lots of 11 over 19 plus 3. So 2y equals minus 55 over 19 plus 3 is going to be 57 over 19. So that's a minus 55 plus a positive 57. So that leaves us with 2y equals 2 over 19. And then we want to get it down to the value of y, remember? So to get to y, we need to divide by 2 on both sides. That leaves us with y equals 1 over 19. So our answer is x equals 11 over 19, y equals 1 over 19. So that is solving simultaneous linear equations. Remember, put them into the form where you can get your y's in one column, x's in the other. You want a common coefficient that you can either add or take away so that you can eliminate one of the terms, solve for either x or y, and then put that value back into one of the equations to find the other term. So thanks very much for watching. This has been Maths with Mitch. Please subscribe to the channel and join me for the next episode where we're going to be looking at sketching quadratic equations.